Okay, so we're going to just pick up where we left off, which was on problem 10 of sample exam 3A. And I think we're on page 3. For this next one, this is a two-way table, so we're doing a chi-square test of independence kind of stuff. And what we want to do here, we want to identify the largest residuals, and on the chi-square, you just take the observed minus the expected values. Oops. And so for this top one right here, we take 45 minus 33. Sorry, I can't write today. 33.77, and so that gave us 11.23. And that's how we got this value right here. 11.23. And so I went ahead, since that's pretty easy, and just did them all. So we have some positive, some negative. When there's two rows, if one of them's positive, the other one's going to be negative. And so the question asks us what cells have the largest residuals, and explain what that signifies in context of the data. And so we can see that the largest residuals were for the math science group, and we're looking at gender and favorite subject area. And so more, because this is bigger than that, we have a positive residual. That means the observed was bigger than the expected for the males, and then down here the females were less than expected. And so I would just want to write a few sentences, maybe just one sentence describing that. So I would say the math science subject had more than expected, had a more than expected number of males and less than expected number of females. Okay, and that's all I really need to write. But maybe if I felt like it, I could continue. So the other two, both other subjects, had more than expected for the number of females and less than expected for the number of males. Okay, so it seems like the men are favoring the math science subjects and the women are favoring the social science and humanities, according to this survey. All right, so let's move on. The next one, we're given some StatCrunch output, and we're asked to do a hypothesis test and also interpret a confidence interval. And so there's no computation here. All you're doing is showing that you know how to read computer output. And we'll go ahead and do the first one. So the question is, what is the question? Do females have more Facebook friends than males? And so this is a one-sided test, and we're going to assume that the females was the group 1 because it's mu1 minus mu2 is greater than 0. Okay, so this is how you can write the null and alternative, or you can write that mu1 is equal to mu2 and mu1 is greater than mu2. That's fine, but that's how you would write the null and alternative. And let's see. So we want to do give a conclusion using a significance level of 0.05. So here's our p-value right here. It's labeled p-value in our table. Here's our test statistic if that's what it's asked for. So our p-value is less than 0.0091. I'll write the conclusion down here. So we can reject the null and conclude that on average, female students, because I think this was a survey for actually Chico State students, we'll just say students, have more Facebook friends than male students. Okay, so that gives us a conclusion for the hypothesis test. The next thing we want to do is interpret the confidence interval. That's always a little more difficult. Because we rejected the null, we know there is a difference between males and females, with females having more, and the confidence interval is right here. Here's the lower bound for the confidence interval, here's the upper. And because we're taking females minus males and it's positive, we know that females have more Facebook friends on average by this much. And so I want to state that in my interpretation. So we can be 95% confident that, on average, females have between, I'll just round up to 7 and 74 more Facebook friends than male students. I should really put students in there just because I think the survey was students. So we can be 95% confident that on average female students have between 7 and 74 more Facebook friends than male students. So this word here, more, is very important. I'm not just saying that there's a difference, I'm saying that females have more Facebook friends than males. All right, I think, is this the last page? I think so. Okay, so here's the last page, and I think we'll be able to finish up this problem. So here's another example where we're comparing men and women. These make for good two-sample problems. And the question was a survey and wanted to know, it is morally wrong for married people to have an affair, and they recorded the number of women who said yes or agreed, and then the number of men who agreed with that statement. Okay, so let's go ahead and state the null and alternative. Now we're getting back to a two-sample proportion, and so I want to make sure my null and alternative has the letter P in it because we're looking at proportions. And I like to use a subscript W and M or F and M, doesn't matter. So the null hypothesis would be that the proportion of women is equal to the proportion of men. And then the alternative, this is a two-tailed test because it's different, so there's no direction specified. So P, W, not equal to PM. All right, so we can calculate the test statistic. If you go to your calculator or go to the formula sheet, we're dealing with a two-sample proportion. Here's the formula. It looks a bit intimidating, but it's not too hard, and we'll do this. But for the calculator, folks, you're going to use number 6, 2-prop z-test. Okay, so I need to calculate 3 things. If I'm going to do it by hand, I need p hat 1, p hat 2, and then the p bar, which is essentially a weighted average of the two sample proportions. Okay, so the proportion of women, that's going to be 347 divided by 386, and so that's equal to, oh, let's put W there, that's equal to 0.899. And then the proportion of men is P hat with an M. That's going to be 305 divided by 359, so that's going to be 0.850. And this P bar, I'll go ahead and write this one out because we haven't done that yet, is the sum of the numerators, so 347 plus 305 divided by the sum of the denominators, so the two sample sizes. So 386 plus 359. And this is equal to 0.875. Okay, so I'm going to calculate my z-score using that formula that's in the back on the formula sheet. Not in the back, on the formula sheet. So I take 8.99 minus 0.850 divided by the square root. And then on the bottom, I'm going to use this 0.875. So I take 0.875. Oh, it's not working. Come on. 0.875. Come on. 0.875. There we go. This is going to be a little messy. Times 1 minus 0.875. So that would be 0.125. And then I divide by my first sample size, so 386. And then I'm going to need to extend this further. This is not working good today. All right. This isn't as easy as it looks. Okay. Pretend that square root sign is getting extended. And then I take 0.875. I don't know if I could do this any messier. Times 0.125 divided by 359. Okay, I'm glad I got that over with. So that equals 2.02. And I want to look that up on the normal table, which hopefully I have. There it is. So 2.02. Here's 0, 1, 2. So 0.9783. However, we're going to have to subtract that from 1 and then multiply by 2. And so the p-value it's a two-sided test, so we take 2 times 0.0216. And an easier way to do that is just look it up as if it's negative when you have a two-sided test. So the p-value is 0.0432. Okay, you can do this on your calculator using the 2-prop z-test. And we're going to use a significance level of 0.05. I'm not sure if it's stated there, but it is. So let's go ahead and use 0.05. And we can reject H naught and conclude that men and women agree with the statement at a different rate. It's just another way of saying that the proportions are different. So men and women differ with respect to how much they agree with the statement. Okay, so I'm going to end the video here, and then there's just 2 more problems. The next video will be super short, but I think we'll end this one right here.